Okay, this video is on enthalpy. Enthalpy is change of internal energy and work, or in our case, at constant pressure. Enthalpy is equal to heat. Now, enthalpy has a designation of H, therefore delta H for a reaction is just about close to our heat. So that's something good to know. What else do we know about enthalpy? Well, it's an extensive property. Extensive means it can be manipulated. If we have twice the amount of moles, you have twice the amount of heat that's produced. That makes sense? All right. We also know if in a reaction, if I reverse the reaction and go a different direction, my sign changes. So in this case, methane is being combusted to form carbon dioxide and water. And here, I'm taking carbon dioxide and water and forming methane. My signs will change from negative 890 kilojoules to a positive 890 kilojoules. This also links with our conservation of mass and energy, is that we cannot, whatever amount of energy we use in one direction, we have to use the same amount of energy in the other direction. Nothing's created, nothing's destroyed. Going from A to B is one point, a negative reverse of that, the negative is going from B to A. So, if I flip an equation, the sign will change. Period. Excellent. Enthalpy changes is a state of the reactant. States are more important now than they used to be. So the difference between gas and liquid is a lot. When you are looking up tables for this, make sure you're looking at the right phase. One of the most common mistakes is that you write down, H2O as a gas, and you write down the liquid version, or you look up NO2 as a gas, and you write down the liquid version, or whatnot. Focus on the states. Make sure the states are constant. And if you have a question, be sure to ask. Because different states have different intermolecular forces and they absorb different amounts of energy. So it makes sense that the state matters when we're talking about how much heat comes from that molecule. So we can do a quiz, a great example. We worked on something like this in class. Given a set of grams, converting to molar mass, calculating moles, and then finding the final amount of energy produced by that many grams. Excellent, excellent problem. It will be on the quiz and it will be on the final. Something along this line. Let's see what else we got here. So I want to talk about practice exercise 2 again. So let's do that. Let's see, we'll call this 2C. We have hydrogen peroxide decomposes to water and oxygen with a negative 196 as our enthalpy for the reaction. Calculate the heat produced of 5 grams of H2O as it decomposes. Excellent. 5 grams of H2O2. So we have 5.0 grams of hydrogen peroxide. Okay, and in my how many moles? How many grams is in 1 mole of H2O2? Well, oxygen is 16, so that's 32, and plus 2 more is 34 grams of H2O2. Excellent. Now I'm in moles. Now, if I look at my reaction, I have 2 moles that will produce. I have here. I have 2 moles of H2O that will produce this many kilojoules per mole. Right? I have this many moles produces this many kilojoules. Excellent. Negative 196. Cool. And this will tell us, so we'll do some quick math. We have 5 times negative 196 divided by 34 times 2. Alright, so negative 5 times 196 divided by 34 times 2. Alright. Looks like negative 14.4. Negative 14.4 kilojoules is produced from 5 grams of H2O2. Excellent. So, great example with problems I put on quizzes. Keep track of this. Cool. Coming down in calorimetry, I do want to talk a little bit about calorimetry and heat. So in our concept of enthalpy, we're talking about heat. Now heat is determined by the mass of the substance times the specific heat, the amount of energy it takes to raise 1 gram 1 degree Celsius, times our change in temperature. Now this small p shows us that it's at a constant pressure, and that's okay. So if I have, for example, 15 grams of water with a CP of 4.184 joules over gram Celsius. My change in temperature, well, I have, my initial my final temperature could be, 98 degrees C minus my initial temperature, 25 degrees C. Right? And as you see, we have this great setup question. Grams cancel out grams. Degrees Celsius cancels out Celsius. We're left with just joules, which is a form of energy, which is heat. Perfect. So this, remember this. Form of energy. Also a form of energy. Q is also equal to delta H, which is enthalpy. Sweet. All right. So here, and these are just 3 variables that we multiply in. This is given, always. I will give that to you. And you can just substitute the rest in. So let's do it. 15 times 4.184 times the difference between 98 and 25. Go to my calculator. Looks like 4.58. Looks like 4.58 kilojoules. Excellent. And notice I quickly switched from joules to kilojoules. That's fine. Just multiply by 1,000. Excellent. So that's our heat. And this makes sense because, well, if I'm going to go from a temperature initially of 25 degrees Celsius in this beaker of water, if I have a beaker under a little stove, a little stove, all right. And went from a temperature of 25 degrees up to 98 degrees. Obviously, I had to add heat somewhere, right? Usually from the stove into the water, and I start boiling my water. Well, that added heat, and which means this is an endothermic process. I added heat into the system, and it increased the temperature. How much energy did I add in? 4.58 kilojoules. So that's how that works. Definitely going to be on the quiz. Very, very important. If you have any questions, let me know in class. Thanks.